Assalamualaikum warahmatullahi wabarakatuh, and a very good day and good news to you. My name is Adymukhlis bin Samah, and now I would like to present to you about my final year project, which is evaluation of antioxidant activity of active film prepared with phytosan and sake inchi leaf extract. Sake inchi leaf extract were popularly used, but there is no research on the sake inchi incorporated with phytosan film. Hence, the purpose of this study was to develop novel active film with antioxidant activity based on phytosan with the incorporated of sake inchi leaf extract for food packaging application, as well as determine the DPPH antioxidant, total phenolic content, and total flavonoid content. Like it was sake inchi plant, the leaf, and the fruits. Product that have been developed, which is the phytosan film. Phytosan film incorporated with 0.5% of sake inchi, 1.0 of sake inchi, and 1.5 of sake inchi extract. The objective. The objective is to develop novel film of active film with the incorporation of sake inchi leaf extract for food packaging application. Next is to evaluate the antioxidant activity of extract and phytosan film that is incorporated with sake inchi extract using DPPH. Lastly is to evaluate TPC and TFC of extract and phytosan film that incorporated with sake inchi leaf extract. Is the hypothesis. My hypothesis is the H0 is the activity packaging film has no antioxidant activity, flavonoid and phenolic content. For the H1 is the active film packaging film will show a good antioxidant activity, total flavonoid and phenolic content. We will be moved to the methodology. The first is plant material. The plant was obtained from a farmer in Macho, Kelantan as 300 gram of sake inchi as crude leaf. Is the extraction of sake inchi leaf. On the extraction, the method was followed from Chin 2050 article. The leaf was cut into pieces and left under the sun for 3 days. Afterward, freezing and drying the ethyl alcohol after it is constantly dissipated and concentrate to be 0.5 gram per ml. Then, the extract will live in the chiller for 4 Celsius until the use. Is about preparing the phytosan film, where it was prepared by following the Abdul 2019 method with some modification by dissolving 2.5% of phytosan, 1.5% of glycerol, 1% of acetic acid in a beaker, heat using hot plate and continuous stirrer using magnetic stirrer for 50 minutes. The solution then measured to 15 ml per film and put into the battery dish. The battery dish then heated in the oven with 7 Celsius for 2 hours. Is the dissolution of the film and extract, where it is dissolved by using distilled water to make the stock solution, meaning the pH antioxidant. The observed reading was found by using the spectrum photometer. The reading was calculated by using the radical scavenging acid percentage, and IC50 was determined. The total phenolic content. Total phenolic content was determined by using Pauling Q reagent, and the reading of concentration were taken by using gallic acid standard. That is the determination of flavonoid content. Aluminum chloride reagent were used, and the reading of the concentration were taken by using Constantin standard curve. The statistical analysis. The data was collected in triplicate and expressed as mean plus minus standard deviation. After that, the data was analyzed by using of one-way ANOVA test and by using Microsoft Access application for Windows, and the p-value are less than 0.05 considered as significant. We're going to move to the result in this discussion. Here is the result of the DPPH. Pure phytosan film showed 30.78% DPPH radical scavenging ability, which is might be because that the capacity of residual free amino group of phytosan to react with the free radical forming stable macromolecular radicals and ammonium groups. Meanwhile, sake inchi extract show the higher percentage of radical scavenging assay toward the pH, which is 97.42%. The pH radical scavenging assay are significant increase as sake inchi extract concentration are increased. The film incorporated with 1.5% sake inchi extract contain the highest percentage of radical scavenging effect, which was found to be the most active radical scavenger. The interaction between phenolic compound and phytosan molecules could influence the DPPH radical scavenging ability of the films. Similar trend had been reported by Sripatrawan and Harte 2020. Hence, the substance with a lower IC50 has a higher antioxidant activity. Hence, the lower IC50 value was from the higher sacha extract, which is 1.5%. So, the reading of IC50 are 0.105 microgram per mole. Next is about the discussion of the total phenolic content. TPC activity is the process to figure out the amount of phenolic content in the sample. Phenolic compound that contain in the plants have redox properties, and the properties allow them acting as antioxidant. Aside from that, it is indicate that in the gallic acid standard curve, the greater the absorbance readings, the higher the concentration. The phenolic contents can be used as an important indicator of antioxidant capacity. We use as a preliminary screen for any product when indeed antioxidant in food packaging materials. The results show the total phenolic content of film extract significantly below 0.05, increase with increasing sacha inchi leaf extract concentration. Is the discussion of the total flavonoid content. TVC was offered in a yellow color, and so the figure show that sacha inchi extract and chitosan film incorporated with sacha inchi extract in prepared serial dilution on determination total flavonoid content. The sample of film that incorporated with sacha inchi extract exhibit significant value of the sacha inchi extract are also significant. The higher the absorbance reading, the higher the concentration in quercetin standard curve. Flavonoids are probably the most important natural phenolics. TFC in the extract was determined by the spectrophotometric method with aluminum chloride. The flavonoid combined with aluminum to form a complex flavonoid aluminum that could be measured at 415 nanometer. The most abundant flavonoid which has a good antioxidant property is quercetin. Aluminum chloride form acid stable complex with the C4 keto group and either the C3 or C5 hydroxyl group, flavonous and flavonols. According to the basic concept of the aluminum chloride calorimetric method, it is also form acid label compound with the orthodihydroxyl group in flavonoid A and B rings. Flavonoid were measured using the aluminum chloride calorimetric method. In this analysis, it showed the good activity of concentration value when sacha inchi extract are increased. About the correlation of TPC, TFC and antioxidant activity. The correlation between the TPC, TFC and their antioxidant activity were done and displayed in correlation coefficient R square. Values from the linear regression analysis with the correlation coefficient which ranged from -1 to +1 and is denoted by R. Positive correlation was observed between antioxidant activity and phenolic compound. The results show that IC50 has a positive correlation with UPH antioxidant activity. R square 0.8149, while TPC have a positive correlation with TFC antioxidant activity, and the value R square is 0.29488. The correlation indicate that the richness in phenolic compound, especially higher flavonoid content, leads to better DPH scavenging activity. The results suggest that the antioxidant activity of sacha inchi leaf might be attributed to the presence of flavonoid to react with the DPPH, TPC and also TFC. As a result, flavonoids can be utilized to predict sacha inchi leaf antioxidant potential. The DPPH result would be strengthened by the favorable connection between antioxidant and IC50 value. This study demonstrates the increasing total phenolic component in extract increase the antioxidant activity, which in line with earlier finding, and increasing the concentration of sacha inchi extract in each test. Furthermore, the antioxidant activity of sacha inchi leaf could be attributed to the presence of non-phenolic compound as well as other synergetic or antagonistic compounds. In conclusion, the presence of phytochemicals such as phenols, flavonoid and UPH antioxidant in sacha inchi leaf extract was discovered. Phenol and flavonoid are contribute to antioxidant sacha inchi leaf will need to be identified through further research. This unique active film have a lot promise for being developed into food packaging materials. In this environment, the development of biodegradable food packaging from the leaf extraction was a vital movement on getting a better film. Thus, it could be a great factor to satisfy the consumer experience the best antioxidant film as active packaging, and would be an opportunity to promote Saka Inchi as a better antioxidant product, since it been reported from several research and attracts their attention due to environmental pollution caused by conventional biodegradable plastic. As a recommendation, I require to identify other chemicals component in Saka Inchi leaf, and I would suggest to providing a film limiter with heat for a better experience in process of developing active film or membrane, neither chitosan nor other substances. And that's all from me. Thank you.